welcome to another video, and today we're going to solve another DFS question called Symmetric Tree. So as the question suggests, you can see that we are given a tree. Let's redraw that particular tree that starts from 1, 2, 2, 3, 4, 4, and 3, right? If you see that, if you cut the tree into half in the middle, the left section and the right section are two mirror images, right? Exactly the opposite thing. And that's what when these particular condition get satisfied, at that time we can call that particular tree as symmetric. So how we're gonna check it? We're gonna run the same DFS. We're gonna go until the last leaf node, and from there we're gonna start checking. So to do that, let's redraw the tree again, like 1, then we have 2, 2, 3, 4, 4, and 3. So we don't have to check our root because this particular root will be the same for both the tree, left and right? Then we have to start checking from our left node and right node. Here the left node will be our 2, this particular node, and right node maybe. This is our left side and this is our right side. So now if we start looking, first thing we're going to check is what? If we're going to keep going to left, right? And same way if going to right or left, other side, right? So we're going to go to right. So if both are become null, it means it is a symmetric. Anytime our P and Q becoming null, it means we covered checking all the nodes and it is symmetric, right? So we can pass our 2 here. If not, we have to, every time we go further below one root, we have to check the value of this root, right? Node value. Whenever we pass the node to our recursive backtracking function or DFS function, we have to check if the node values are same. If node value are not same, then it is a false, right? And then here is the trick, a main trick. The left of this node must match what the right side of the right node. So this is our left, this is our right. So first condition, our value should match. Second condition is the left side of the left node, that is 3, should match the right side of the right node of the right. You're getting the point? So we are flipping the values of the node every time we are calling the recursion, and that is the only thing here tricky, and everything is like simple DFS. So that's just we have to flip the time you are calling the logic to check or to match our values. At that time we have to pass left of the left node and right of the right node. Similarly, right of the left node we have to compare with the left of the right node, this node. This is the flipping things here, and we will get our solution. So now let's see how the solution looks in code. Okay, then let's write our logic. So we need a DFS method, function DFS, and DFS will take 2 nodes. One is for root.left, another is root.right. So we have to create 2 input. Let's make it P and Q, and at the end we have to return DFS, and this function will take our root.left, root.right. Perfect. Now we're gonna write our logic. So first thing first, if we cover all the nodes and reach the null for left and right, it means our tree is symmetric and all the checks and passed, and we have to return true. So if not p and not q, return true. True. Now we have to check if p is present but q doesn't, or q present and p doesn't. It means our tree is not symmetric and we have to return false. So that case we can cover as else if not p or not q, then return false. Then we have to go for our logic. First thing is we have to check the node values. The values should match. So p dot val equals to q dot val, and we have to call our DFS by tweaking the value, right? Q's left with p's right and q's right with p's left. So that's we're gonna do here for p dot left with q dot right, and q, and again we're gonna call DFS p dot right and we're gonna pass q dot left. And this should solve our symmetric problem. Let's now run the test cases. And it passed. Now let's try to submit it. Test cases are passing. Perfect. So it's passing. Thanks for watching. See you in our next video.